we go on, and I'm feeling more fresh now. Let's go for it. We're doing part B. Since when do we struggle with graphs? We don't struggle with graphs. So f of x is just going to be equal to, we know what piecewise wants. It wants two parts. So we are doing if x is less than 0, and then it'll be x plus 1 if x is greater than or equal to 0. So this is going to be easy, because the plotting 2 is very simple. We only have to work with this one for x plus 1. Let's do it. So we can say for x greater than or equal to 0, we can now say f of x is equal to x plus 1. Okay, now we only need 2 points, really, and remember that x should be greater than or equal to 0. So if it's greater than or equal to 0, I only need 2 points, yes, to plot a line, because the highest power of x here is 1, which means this is going to be a line. If it was x squared, then it's going to be like this or like that. If it was x cubed, then it goes down, then up somewhere, okay, or up, then down somewhere. That's what it does. Just does those two only, to go up, then down, or down, then up, then stops. So, but x squared is just like this, then, or like that. All right, now, we want to do, and for x, when there's just the highest power is x, there's no power bigger than or higher than x on, or higher than 1 on the x, then it's going to be a line, and we only need 2 points. So we can do 0 and even 2. So f of 0 is going to be 0 plus 1, which is just a 1. F of 2 is equal to 2 plus 1, which is going to be 3. So now we can do that. So we don't even need to put that long a thing, right? Now let's sketch the graph. We can sketch this graph. This graph is so easy. So, I mean, by the way, sorry, I'm going to the last end. We should label it. This is going to be f of x equal to, this is 6 minus x, because it's a line. Then for the curve, this is going to be x squared. So you can come here and say f of x is equal to x squared. Now let's come and do the same here. Let's solve now. What are we going to do? We want to sketch our graph. So we start with x less than 0. Okay, from 0 going up, we know that it's this one. So we should put, we can put our small table. We can put our small table, which is x and f of x. Okay. When x was, we put f of 0, that means when x was 0, and we did f of 2 when x was 2. When x was 0, we got 1. When x was 2, we got 3. So that means we do 0 and 1 on the y. Okay, this is the y-axis. Here's the x-axis. This is the y-axis, okay? So this is 0 and this is 1. This is 2, this is 3, this is 4. So it's 0 and 1. So that's the first point. Then the second here is 1, then 2. When x is 2, we got y3. So it comes like this. All right, so this is what it's going to be doing. Then what about on the other side of this line? What is it going to be doing now? It's going to be just a 2, which means it's going to be just like this here. So it comes all the way. So it just comes like a 2. It will be a 2, which is, it will be flat like this. It goes all the way, but it gets here. It does not include this point, so it leaves it blank. Then here we draw another thing which joins these two stars like that, going like that. This is the other one. So we have our two graphs, okay? How easy is this? So this is now f of x equal to x plus 1. Then here we have f of x equal to 2, right? And now we have done this. This is f of x equal to 2. This is whatever. Look, the reason I didn't include this point is because it's not there. This graph, this thing is only for greater than 0. X, if you see here, it's for x less than 0, only less than. So this f of x equal to 2 is only for less than 0. So when it's less than 0, your f of x, which is y, will be just 2. So that means this should never should never arrive at x equal to 0. It goes like this and it just touches this. Then this is what happens. This point is not included. But for here, the point is included and it keeps going. So now anyway, you can put the points -1, -2 just for neatness, you know what I mean? Although we never use them. Then you can put just 3 and 4. Done. So this is something like it, and you are done. This is all we needed to do. Now let's see what limit we are approaching. Are we approaching the same thing? Okay, so if I'm coming from the left, I'm coming from the left like this. What number am I going to? What y value am I going towards? I'm coming from the left. I'm going towards a y value of 2. This is just the same y value. So I can say the limit for part I, the limit as x goes towards 0 from the left of f of x is just a 2. What about for the second one? Now we can say, for the second one, we can now say the limit as x approaches 0 from the right of f of x. This is going to be, let's use the graph. We are now approaching the right. We are coming like that. What is our graph going towards? Is going towards a value of 1. So this is going to be equal to 1. So now, what is the limit here? So you can now say since limit, you can say since, you can now put limit as x goes to the left, or you can put it in the line, I don't know. Since limit as x goes to 0 from the left of f of x is not equal to the limit as x goes to 0 from the right of f of x, they are not the same. And if they are not the same, then that means this two-sided limit doesn't exist, because this is a one-sided limit, it's from the left. This is a one-sided limit, it's from the right. This is x approaching 0 from both sides, which is a two-sided limit. It only exists if the one-sided limits are the same, are giving the same answer. But here, these one-sided limits are not giving. One is the same answer. One is giving 1, one is giving 2. So we can say, therefore, we can now say, therefore, you put therefore on the same line, then you finish on the other line. You say, therefore, you can now say now, limit as x goes to 0 for f of x is does not exist. Okay, so you can say it is equal to does not exist, or you can say it does not exist. Okay, then you are done. All right, this is what you have to do. Okay, you can just put D and E to say it does not exist, but you should put it in it does not exist. Then you are done. This is the solution, and we can move on to question 3. Goodbye for now.